Good say.
All right, so tell me, children, what does it mean when I say that figures are congruent? I think I heard the right answer. Good, so what Emily said was same angle measures and same side lengths, which is exactly right. A faster way to say that would be congruent means they are the same size, same shape. Congruent means same size, same shape. And if you want to give the technical geometry book definition, Emily's is probably more correct. Same angle measurements. That's what gives you the same size. Same, no, I got that backwards. Same angle measurements is the same shape. Same side lengths gives you same size. This is different from figures that are similar. What does similar mean? Okay, be more specific.
You have one or the other, same angle measurements or same side lengths?
Yes, but they don't have both. So you would say like just the same angle measurements. Similar figures are same shape, but not necessarily same size. A teeny tiny triangle and then an enormous triangle that has the same angle measurements are similar. A dilation is an example of something that would give you a similar figure. In fact, let's talk about that. Not yet.
Just right now.
Funny you should ask. Transformations that create congruent figures. Do you remember your transformations?
Reflection. Did you say rotation?
What kinds of transformations are all of those? Rigid. So any rigid transformation, which is all of them except dilations, as far as you know. Of the ones I have introduced to you, they are all rigid except for dilations. Ooh, that highlighter is out of control. Any rigid transformation. And you just gave me a list. You said those are rotations, translations, reflections. Not dilations. Dilations are the bad ones. Dilations cause a figure to be larger or smaller. If a figure becomes larger or smaller, it's not congruent because it must be the same size. When you dilate something, it's not the same size anymore. So not only do congruent figures have the same angles and the same side lengths, but the order in which you name your congruent figures tells you which ones are the same. Por ejemplo, if I were to give you two triangles, did you say huh to por ejemplo? You're in Spanish, you should know that.
We're not there yet.
Por ejemplo means, for example. You're in Spanish, children.
But I learned that last year.
So if I told you that triangle ABC was congruent to triangle DEF, and I really do have to write that they're congruent because my pictures do not look the same. But let's pretend like I did a perfect reflection here. The order in which I named these congruent shapes tells me which specific pieces are congruent. What I mean is, whenever I named triangle ABC, A was the first letter that I wrote. And in the second triangle, the one I said it was congruent to, D was the first letter that I wrote. Since both those letters are in the first position of the name, it means those angles, angle A and angle D, are the angles that are congruent to one another. The letters in second position are B and E, so that tells me angle B is congruent to angle E. That's really helpful because if I just look at the shapes, I would have to sort of reflect it in my brain to figure out which one went where. Not a huge deal with the reflection, but if I did a reflection, a rotation, and a translation, it might be hard for you to mentally do that and figure out, okay, which angle lines up with the second one? Can you explain to me why I had to do two doodly dids for the second pair of angles instead of just one? Yes, ma'am. Exactly right. B and E are congruent to each other. They're not necessarily congruent to A and D as well. And so my letter in the third position, C and F, have to have three doodly dids. Also, what'd you say? That's why I did two, but I didn't have to do two. I could have done three if I wanted to be a weirdo. That's the kind of thing Emily would do. Emily will do one line for the first one, 3 lines for the second one, and 8 lines for the third one. Not only does the order matter for angles, it also matters for sides. So for example, the first 2 letters are AB, and then in the second triangle, the first 2 letters are DE. That tells me that side AB is congruent to side DE. The last 2 letters were BC and EF, which tells me side BC is congruent to side EF. And then the only combination that's left is the first letter and the last letter, so AC and DF are congruent. And again, I will do those with 1, 2, and 3 doodly dids. So here's my question. Do I need to know all of the parts to know that triangles are congruent? Maybe 1 or 2? What's the smallest number of pieces you think I would need to know in order to prove triangles are congruent?
Could you just be given the ABC is congruent to DEF? Are we talking about just using it?
Like if I just told you angle A and D were congruent to one another, and angle B and E were congruent to one another, would that be enough for you to prove that C and F were also congruent to one another? Sure, because if you know 2 angles, you know the third one, right? Would that prove that the 2 triangles were congruent? I would need sides. How many sides do you think I would need?
2.
2 sides? Could I get away with 1, maybe? Would I need all 3? That sounds like an important thing for us to learn over the next few days. What are some ways that I can prove triangles are congruent without finding literally all 3 sides and all 3 angles? That's where we're going with this eventually. For right now, not today, but tomorrow probably. For now, what I want you to know is this phrase, corresponding parts of congruent triangles are congruent. This is the kind of phrase that comes up a whole lot in proofs. Corresponding parts of congruent triangles are congruent. Meaning if I tell you these two triangles are congruent, then you know every single piece of the triangles are congruent to one another, just like what I showed you. Because this comes up in proofs so frequently, and because this is a very long thing to write, we will often abbreviate this as CPCTC. Corresponding parts of congruent triangles are congruent. So what this allows us to do is if I say triangle ABC and triangle DEF are congruent, you can then say, oh, well, in that case, angle A and angle D are congruent. That's what this proves. If I tell you the triangles are congruent, that means every single piece of the triangles are congruent. What we're going to work on after this lesson, meaning tomorrow in the next few days, is could I prove triangles are congruent without knowing every single piece of the triangle? And the answer is yes, but what are the pieces that I have to know? What's the smallest amount of work I have to do to prove triangles are congruent? The answer may surprise you, but probably it won't. Okay, I'm going to draw some weird shapes for you. You only have to draw these if you want good notes. If you don't care about your notes being good, then I guess you can. Chocolate on the
Someone's got Willy
brain.
Wonka on the brain.
I read Willy Wonka one time. We're going to call this quadrilateral QRSP, just to annoy Emily.
That's not bad.
I know, I just said it in the wrong order to bug you. And I'm just going to go ahead and tell you that these are congruent.
Are you teaching us not to allow diagrams?
How dare you? These look exactly the same.
You're exactly the same.
Yeah,
Just
just
think
don't know
you
the
are
rest.
exactly the same.
Which just means they're not exactly the same.
You are so rude to me.
I mean, you told us don't look at the diagrams. So technically you got that on yourself. Don't go blaming us.
Mr. Taylor makes you feel better. Mine sucked too.
That does not make me feel better. Why did you have to say two? Same, girl. Same.
Is that 10.6?
Yep. It's 10 and 6/10.
What's the degree for piece?
For which one? 49. 49, 127. And diddly did. I have given you enough information to figure out every single piece of the other quadrilateral.
Yes, yes, he did.
So give me another piece of the quadrilateral. The quadrilateral that's missing everything.
XW is 15 centimeters.
XW is 15. How do you know?
Because if you look on the equation, it's PQ is the first two, and WX is the first two.
PQ and WX are corresponding.
So then,
Since PQ is 15, WX must also be 15. How do you know? Good. The last two letters. RS is the last two. YZ is also the last two. So those are corresponding parts. Since I told you that these two shapes are congruent, corresponding parts of congruent figures are congruent. So I could say that YZ is also going to be 8 centimeters. Why?
Fiddly doos.
Right, it's the middle two. QR is the middle two letters. XY is the middle two. So QR and XY are the same. And we know QR is 8 centimeters because we've got the diddly doos. That mean they are congruent. So this is 8 centimeters. No. Well, we're not done with the sides yet. Right, 10.6. I don't even really need to do any checking the position there. There's only one side left, and the original triangle is 10.6, so it's got to be there. Okay, so let's talk about angles then. Y is 90 because R is in the third position and it's 90. Y in the third position then must also be 90. Well, that's true, but we already did that. Yeah, we already did the sides.
PQR and YXW are congruent.
Yes, Ellie says PQR and YXW are congruent, but we don't know how big PQR is.
I didn't see what I did.
They are congruent, but we don't know what they are yet. Let's do one of the ones we have, 49 and 127. Where do those go? 127 is at Z because angle S and angle Z are in the same spot, and angle S is 127. Good. W and P are in the same spot, 49 degrees. How am I supposed to figure out that missing angle? 360. A triangle has 180. A quadrilateral is 360. So I can do 360 minus the 90, the 127, and the 49. And Emily says the total is 94, and I believe her. So that means this one is also 94 degrees. Good. I have decided to build a roof for my shed by combining two congruent triangles together. I want it to be symmetrical, so I'm using congruent triangles like a good boy should.
Is this going to take up a lot of space?
No. Two congruent triangles, as you can see from the drawing, perfectly congruent triangles. Thank you. What a polite young lady. I'm combining two congruent triangles. I want you to find the perimeter and the area of the entire shape. How do you know? Yep,
They're saying together.
because 4 plus 4 is 8,
Oh,
I think. Use your calculator, check me. Sometimes I mess up, but I think 4 plus 4 is 8. I actually have enough to do the area right now, don't I? Because what's the formula for area of a triangle? 1/2 base times height. What's the base in this problem? 8, and the height is, well, that's going to be easy. Yep. 8 times 3 is 24, and half of that is 12. So the area is 12. What's the unit? Rowdy, what's the unit when you're doing area? It's not feet, square feet. Thank you, Rowdy.
Sorry.
Jeez. Rowdy, you sound so
I
feminine.
didn't know.
Really? I thought you were the construction guy. When you do flooring or something in your house, or when you're doing shingles on your roof, it's area. So all of the measurements are done in square feet. When you go to the,
That's for TJ to do. All me and my dad do is we go through and do whatever he says.
yeah, but don't you want to be the boss someday?
No, not really.
Really?
My
You'd be-
dad says that the reason why he likes doing what he's doing because he can actually tear stuff up and get paid for it.
well, that's genius.
Okay, we don't have enough information to do the perimeter.
You don't find the other two. That's what you do. That's what you
A squared plus B squared equals C squared.
We could do the Pythagorean theorem,
Aw,
we could,
It's so much
Please
fun.
do that. So let's do that.
but
It's something.
this is a special right triangle. This is called a Pythagorean triple. When one side is 3 and one side is 4, you should know what the last side is. And if you don't remember the math, you can just remember my SoundCloud. White chocolate, 3, 4.
5.
If two sides are 3 and 4, the other side is 5. That's why my SoundCloud is white chocolate 3, 4, 5.
All makes sense.
It's a Pythagorean triple. 3 squared plus 4 squared is 25.
Wow.
So
Are you sure or you just?
Oh, he's sure I did the Pythagorean theorem earlier to double check him.
so how do I find the perimeter?
I love all the sides together.
Add all the sides together, which would be 5 plus 5 plus 4 plus 4 or plus 8 if you're nasty, which would be 18. 1821. That's not a unit.
No, because plus 3. We do plus
That's not the perimeter. 3 is inside. Perimeter is the outside.
feet squared.
Feet squared is area. Length is just feet. Volume, if I wanted to know like how much could I fill this up with, which would be a weird question to ask, but if I wanted volume for some reason, the unit would be feet
Per inch.
cubed.
Oh,
Feet cubed is volume. How much coffee can fit in my coffee cup? That would be cubic units. I probably wouldn't measure it in feet. Probably wouldn't measure it in feet, unless your cup was gigantic. Maybe inches, cubic inches, perhaps.
Volume of a triangle. Do you do 1/3 base?
The volume of a triangle, it would have to be a 3-dimensional shape, so it'd be like volume of a pyramid, and in that case, yes, 1/3. That's why I said asking volume of my roof would be kind of a weird question to ask because it's flat. Volume would be 3-dimensional. I just wanted you to say cubic was volume. Forget that the question I asked you about volume is dumb. Unit for volume is cubed. And that's all I want you to know about congruent figures for today. The most important thing is that the corresponding parts of congruent figures are congruent. Tomorrow, I will introduce to you one of the ways that you can tell if two shapes are congruent without finding every single piece. There's a bunch. There's like 5 different ways. We're going to learn all 5, but we're not going to learn all 5 in one day. Yeah, congruent figures are really easy. And honestly, the next few days when we learn how to tell they're congruent, those are also pretty easy. The hard part is remembering which ones work and which ones don't. So like if I give you 3 angles, that's not enough to prove they're congruent. But if I give you 2 angles and 2 sides, that is. I can give you 2 angles and 1 side if the side is in a specific spot in between the 2 angles. So the hard part is, I don't want you to worry about that right now because I haven't taught you. But the hard part is remembering which ones will tell you they're congruent. But the actual math part, very simple. You should be done with today's assignment in 15 minutes. It's not tough. Well, 20 minutes because there's a proof. Any questions from anybody about anything other than can you remove the proof? The answer is no.
How many proofs are